Hi, I'm Mike O'Connor, and welcome to the Actualized Self, where each episode we talk with world-class performers and entrepreneurs building a better tomorrow to learn the tools, tactics, habits, and routines they employ to accomplish all that they do. Now, today we have a unique episode because we are interviewing somebody named Harry, who's a medical student, a fellow at the International Space Station National Lab, and the co-founder and CEO of an NSF supported deep tech startup called Otto Sciences. Otto is a really unique company because they're essentially working to accelerate scientific discovery and working on some significant pipeline and commercial challenges in that space, involving researchers and some folks on the private sector side, government entities, and all these other really complicated variables that you're going to hear Harry talk through. Now, today is a unique episode for a few reasons, but the main one being the audio on my end was actually a little bit choppy. So with regards to Harry's talking points, which are really crisp and really good and fascinating, I actually went through the episode and took out all my really feedback-driven, messy audio and just gave you the highlights from talking points with him. Even with that, we've got 20 minutes of content, and Harry dives really deep into some organizing principles he uses to make decisions into things that he's excited about in the deep tech space. Some science fiction like technologies and other things that we see coming down the pipe, and all sorts of other great content. Really cool episode, and again, I really tried to sort of consolidate this down to really sort of give you the best and give you in clean audio. So that's it for prologue. Check out Harry. He's a pretty unique young person, and certainly somebody that's inspiring and awesome and all the good things. So check him out. And as always, let me know your feedback. This is a different style format. I would love to know what your thoughts are, good, bad, and indifferent. That said, thanks so much for listening, and look forward to hearing from you.
Yeah, so I wear a couple different hats right now. The first is I'm a medical student at the Medical College of Wisconsin. And as you mentioned, the second is that I'm the co-founder and CEO of Otto Sciences, a company that's dedicated to accelerating clinical and translational pipelines. So essentially figuring out how can we cure diseases faster and more effectively. And then the third hat that I wear is that I'm a fellow at the International Space Station National Lab. So I do some work within the space sector, figuring out how can we accelerate the commercialization in space, and in particular, how can we use what we're doing in space to benefit humanity here on Earth. So I actually really like variety, and so that kind of keeps my brain juicier and keeps me from getting burnt out. So being able to switch tasks and do things that I'm really passionate about just kind of helped me. And so having a level of organization is obviously important. You have to split your time and make sure you have protected time for certain tasks and, mind share for certain things. But I've just had to cultivate this skill of being organized, and there's certain frameworks that I'll use to make sure I'm giving enough time and attention to certain things in the order that's important. But at its core, it's really things that I just love working on. So it's a long journey, and funny enough, some of it stems from my interest in STEM at a young age. When I was a kid, I loved watching Nova and all of these other shows with Neil deGrasse Tyson. As I got older, I participated in more scientific research, and especially got interested in things that are in biology and medicine, so a little bit away from astrophysics. And there's three broad categories of scientific research. The first is basic science research, then clinical research, and translational research. So basic science research is research that is done simply for the pursuit of knowledge and to satiate curiosity. There's no imperative that it needs to be useful for some purpose. It's just discovery for the sake of discovery. Clinical and translational science are more focused on how can we use what we're learning about certain systems to benefit humans and other things of interest. So in 2019, I had done stuff with all of these, but in 2019, I started going into translational medicine research. In particular, I was doing work at a tissue engineering lab, and we had several active projects, and it was like working in sci-fi. We were using biodegradable magnetic nanoparticles to build tissues from the ground up. We were electrospinning new polymers to build new medical devices, all kinds of cutting edge stuff. We were 3D bioprinting stuff. So it was really remarkable to be able to work on that. And at the same time, I was also shadowing at a children's hospital Trauma 1 emergency department. Trauma 1 just means that you have every specialty on call 24/7, 365. So neurosurgery, orthopedic surgery, ophthalmology, everyone. So if there's an acute clinical scenario that an ICU, a Trauma 1 ICU or a Trauma 1 emergency department can't treat, you're kind of out of luck, because that, quite frankly, that's the best we've got. So when I witnessed the stark contrast between what we're able to do in the lab versus what we have available, in the front lines of trauma care, it was eye-opening. And it got me really interested in understanding how can scientific innovation translate into the clinic. So in other words, from bench to bedside. And in looking at the different frameworks that were available, like going through government, academia, nonprofits, private sector, it seemed that the private sector had a lot of advantages. You can move a lot faster, was principally something that was meaningful to me. And so that, combined with the fact that my high school kind of had a focus on entrepreneurship, those two things really influenced how I started to think about entrepreneurship. And I wanted to look at how can we solve this problem through maybe an entrepreneurial route. And so at that point, that's sort of where we started to look at, okay, we know this disconnect exists. How bad is it? How slow is science moving? How fast is it moving? What can we do? And so we wanted to know, why aren't we getting sci-fi in the clinic yet? And if you've ever wondered how long it takes to cure a disease, the answer is, on average, 17 years. Obviously, that changes per disease, but just let that fact detonate in your mind for a second, like 17 years. So long story short, the National Science Foundation thought that we were onto something. They supported us, and they said, figure out what kinds of things are slowing it down and what can we design to make it faster. And that's how we started Otto. Based on what we heard from people, we started designing our first pilot focused on accelerating some preclinical R&D processes. And now we're actively leveraging a number of programs aimed at different parts of the clinical pipeline. For one, a lot of the preclinical candidates that look really promising at the preclinical stage, it works really well in, in vitro models, or works really well in mice. I don't remember the exact statistic, but I believe it was 12 out of 13 end up failing when they go from preclinical to phase 1. And keep in mind that all 13 looked almost equally promising at preclinical. It's not like you could say, oh, one was better than the other. You had rational reason to believe that all 13 were going to succeed in phase 1. So that's a challenge. It's just the science is hard. And you run into problems with like clinical study design and things that need to get really complicated. So let's say you're treating a disease in older people. You need to account for, if an older patient maybe dies in your study, how do you know that was an effect of the drug or something else? How do you, especially with and another issue is with formulation. So maybe you want to make a drug that, if you're trying to treat arthritis, you want it so that no one likes big pills, but people with arthritis want to be able to actually grip the pills or lick their finger and be able to touch the pill and it sticks to their finger and then it still is able to go down their throat okay. So there's lots of just technical challenges that add up. And at the moment, there's a lot of different things going on with biology, in the sense that there's a lot of intracellular communication and complexity, and we just haven't figured out a good way to sort through that. And I think in the next few years, we're going to see some technologies with that, especially with AI. But there's a lot of challenges, but that's just kind of an overview that there's a lot of technical challenges that add up. I would say just generally, I think one of the most interesting places to be right now is just deep tech. So in particular, biotech, quantum, AI, the space sector, there's just some really cool and interesting stuff happening. With regards to what you're saying about biotech and the use of AI, I think there's just so many different places you can take that. And it's hard, right? Because you have all of these brilliant teams working on these problems, and I really hope that they succeed. Because if you could have an AI that says, hey, look, 6 of these 11 candidates are going to fail, don't waste your time, and here's the reason why, and I can show you why, and all of that. Here's what you should focus on. So if it can design clinical candidates itself, or if it can give you insights into the just massive amount of intracellular communication that's going on, there's just so much that you could do with that information. So I'm really excited about that. I'm really excited about the spaces. I'm really excited about things like synthetic biology. So using biology to solve problems like outside of biology. There was a study a while ago, I don't remember exactly where it was from, but apparently at some point in time you could fit the entire internet, if you put it into DNA, in terms of like information encoding, it would be the size of a shoebox. And so that's a really interesting point for like data storage, which is like becoming a big problem, especially when you look at challenges related to like mind uploading and other things like that, which obviously are very far off. But again, I think the intersection between all of these different deep tech spaces, biotech and AI, quantum and all of that, is really interesting. Yeah, that's a good question. So I'm limited in what I can say just because the different platforms we have active right now are kind of in like a private beta. But what I can say is, there's different stakeholders in all of this. You've got PIs at universities who are discovering things, and maybe they want to commercialize their work. And sometimes they're really good scientists, but they're not. They have a lot to learn about entrepreneurship, and you need to support them in that. Other times you have the amazing power and weight of pharma, like billions of dollars and really brilliant people. And how can you make, slight changes or slight adjustments to that really, little levers that make a big difference for them. And so those are just two of many, but I think those are, to answer your question, you kind of look at the stakeholders, what are the problems that they're having with regards to the pipeline, and then design something with that in mind. And it's fun just to engage with those people too, and learn from them about how they think about these big problems. Because you might spend, 2 decades of your life. I've met people who spent like decades of their lives just curing one disease. And that could be even like an orphan disease. And just from talking to those people, you can kind of feel that perspective and that understanding of like, as a human being, I might use a quarter of my life just on one disease. And that's I don't know, I really enjoy that. I can start with the decision making, and then I'll get into how I prioritize time. So at risk of kind of sounding cliche, I think that the scientific method is a really useful tool set for just thinking about things in work, life in general. Because we live in a world where we don't have all the facts, we have biases and misconceptions, and we're prone to being influenced by our emotions. So being able to take a step back and evaluate something rationally is profoundly helpful. Even if that's, looking at yourself with regards to your workload and what's important, what tasks to prioritize, what's urgent, what's significant, what's the 80% versus the 20%. With regards to entrepreneurship specifically, I really like the lean methodology and the sort of move fast and break things concept. Obviously, that can't be applied to things like, therapeutic biotech, but that can work well with like tech. So I learned much faster by just going deeper and doing things hands-on as opposed to just reading about them. So that kind of thinking about things is where I would start. And then in terms of how do I actually prioritize time, for one, for every project that I have, I'll have a weekly KPI of what do I want done on this. And sometimes that can be as simple as I have no idea what's going on with this one thing, so I'm going to make a list of questions and then see at the end of the week how many questions of these have I actually answered. And so the way that I organize my tasks and projects is actually using a method by Y Combinator that I really like. It's essentially a 3-column spreadsheet. And on the first column, you have the name of the task. The second column, it's titled impact, and it's what is the impact of that task on your weekly KPI. And then the third column is the complexity of that task. So you can have low, medium, high impact and low, medium, high complexity. So any task that is high impact and low complexity gets done immediately, regardless of the project. Yeah. And so I'll typically use like Pomodoro timers to keep myself focused and work through those high lows, and then move to things that are high impact, medium complexity, and then kind of move from there. So that has been incredibly helpful. Yeah. I think we talked a little bit about this with deep tech. I think deep tech is just incredibly exciting. Obviously, there are solutions in tech that are pretty cool too. I really think the health tech space is interesting, in particular health tech that's engaging patients. And for me, I think B2B tech is interesting to a certain point, but personally, my passions are really within deep tech. And I really do enjoy seeing some of the new discoveries that we're getting and thinking about how can we use that to solve a problem? How can we maybe decarbonize with that? Or how can we build a bioreactor that makes sure we never have drug shortages again? How do we solve really big problems with technology? And so that just is really interesting. I'll preface this by saying I have no financial interest in these, but I think Ginkgo Bioworks is really cool, especially with what they're doing with automation in biology. I think that's amazing. In that same vein, Emerald Cloud Labs, and I think there's a company called Synthetake or Synthego. So automated biology is really interesting. Obviously, the stuff that the OpenAI and all of that has been doing, DeepMind, very cool, very interesting. There's also a growing body of like VC firms that are interested in deep tech. So I think like Deep Futures. There's a company called like Basecamp Bio that was doing some interesting stuff with proteins that you can find in nature that you can repurpose for synthetic biology purposes. There's so many. Maybe I can pop some in the show notes. I think longevity is one for sure. Like if we could have people live healthier for longer, especially because, the aging population is growing and we have all of these different challenges. Longevity is really something that's important for the future, and it's going to impact every sector that we deal with. And so if we could have people who are, chronologically 90 be biologically 60, I think that would be really good. I think it would also change the way that we as a society view large-scale problems. And there's, I have several things I could talk about longevity for hours, but I think that is one big problem for sure. Another would be looking at how can we make ourselves more efficient? So maybe through the use of AI or, other things, but how can we really enhance our ability to basically develop catalysts for our innovation? Whether that's for the innovator themselves as a human or someone who works with a human like an AI, just expanding the mind share on certain problems, or the quality of mind share. LinkedIn is probably the best way to get in touch with me or learn about what I've done. Yeah. Yeah, this was fun. Thank you, Mike.